Aero Society. Right, we say a couple of words before we start just about tickets. Take that 30 seconds.
Yeah, can we speak to on the last one? Yeah. Okay, thank you.
Is it working? We don't know how to work.
Yeah, we don't know it.
One.
Oh, can we get some quiet, please? Thank you very much. Right, we promise not to waste too much of your time, and if you're a mechanical student, please ignore me. My name's Tom, and I'm now your first year representative of the Aerostock Society.
And I'm Patricia, your other first year representative.
We've just got a couple of notices for you before we get going. First of all, we have more ticket sales on tomorrow. If you missed out on any of them, they're £5, and you can only pay in cash. The rooms are running from 11 to 12 and then 1 to 6, I believe. And if I just get the room numbers up for you, it's ground floor A28 and then first floor 29, I believe. So if any of you guys can show up for that, that would be absolutely lovely. And then just one more notice to make sure you sign up for Aerostock Society online so you can get you registered and get your events emailed to you, and follow us on Instagram at Aerostock just to have that there for you as well. Right, anything else?
That's it.
All right, thank you very much for your time.
Oh, sorry. Okay, hello everyone. We should start. Can you hear me? Yeah, okay. Hi again. Today will be our second lecture. Now you all have some experience with the first tutorial. It was very different experience, to be honest, because, well, it's something normal, but of course it's kind of problem that some of you have quite an extensive, quite good experience with programming, and it's probably quite easy. By the way, can you raise your hand if you have no experience with tutorials and with coursework? Please. Who have any serious problem with the coursework? Just to understand. Okay. Okay. Who have had considerable problems with this? Can you also raise your hands? No one. Great. Why you wrote me so many emails if you have no problem at all? Well, okay. We will speak about this matter a bit later, but now we should start with our second lecture. And as I said, that's the problem, that you have two different programming experience, and actually who had this experience should start do it actually. And I'm sure that our tutorial is quite basic and quite easy to start with. Pardon, I have its awful system here. So yeah. Well, it's a couple of general words again about the programming itself. In any program, first of all, you have a data. It can be any data. It can be some integers. It can be some, I don't know, number from internet, from experiments. And first of all, you need to convert this data into variables in your program. It's the very first step at any program, that you should realize what your data are and convert this data into some types of variables. It can be, again, numbers, and can be floating numbers, and or it can be some more complicated, like vectors or matrices, which we will discuss today and next week. Maybe one of the first possibility for programming is analysis of your data. You mean you can count your numbers, you can estimate length of your vectors, for example, you can make some statistics of your data. So you can perform some analysis of your data itself. The second thing which you can do is manipulation with your data. It's actually you can do it by some operators like plus, minus, division, and many others. And for each type of the data, you can determine or overload, so-called, your own operator. For example, you can assign a new plus operator for vectors, for matrices, for real numbers, or complex number, for example. And it can be actually, action of this operator can be different for different types of your variables. Anyway, finally, for manipulation of your data, you can have functions. Its functions always have some output, some input parameters and some output parameters. So all the manipulations performs, the function perform all manipulations inside their body, and they give you just some output. It can be very easy output, like yes or no, for example, if you're interested in some properties, in existence of some properties, for example. And the third part, which is crucially important, and most of you faces with a really hard problem, how to increase the size of your program up to 20 words, which was one of the conditions of the first coursework. Well, I have two comments here. The first comment that when some program or debugger or even online system require you something, like increase your program up to 20 words, you need just increase your program to the size which it requires, and nothing less, nothing more. But the second thing, which is much more important, and we will discuss it at the end of this lecture, you need to write your comments or your descriptions for your program. It's not additional features or not mandatory features, but it's crucially important to write some explanation for everything you write in your programs. Starting with your name, year, some title of this program, or at least to describe aim of this program, describe some variables which you use, describe functions which you use. I will speak about all these things further, but it's crucially important, and it will be one of the mandatory conditions for the further courseworks. Okay, then you write some comments to your program, and if you write your some functions, for example, some of you I saw that solve the first coursework problem as a function. You also need to write some function which user can see by the using command help and name of your function. So comments is essential part of your program and not additional. And sorry. So finally, this is the structure, and if you have no programming experience, you should always start with data. You should decide what the data are. Then you should convert your data into variable. Then you should decide which manipulations you need to perform to obtain the results or the results of your problem actually. Then you need to use some operators or functions, and you need to comment all of your program. Simple like this. Well, so first of all about variables. As we also discussed, variables can have different types. It can be matrices, it can be numbers, it can be vectors, and you put them all into your program and then operate with them. Yes, it is important again that MATLAB, not as many other programming languages like C or Python or Fortran, for example, MATLAB decides by himself what's the type of your variables. In other programming languages, you should explicitly write what it is. Well, now more about the numbers. What we should discuss. First of all, yes, there are some extension of usual integer or whole numbers and floating point numbers. It's, for example, it's a complex number. It's like, do you know what is a complex number? Yeah? Who knows? Okay, some of you. I really hope that soon during your first year of education you will teach it, I mean you will learn it in your math course, but complex number is very important, especially in engineering. And for example, two-dimensional vectors or vectors on the plane, you can represent, it's one of the way of representation for vectors on planes. The idea of complex numbers that they consist in two components. One is the so-called real part. It's here, for example, 1, and the second one is the imagine part where you can see some real or integer number times times I, which is the square root of -1. This is the idea. And you can also use some operation, including very special one, like absolute value of 0 and angle of 0. It's related with the presentation of complex number like vectors. But it's another story. The important thing which you can use in your programs, it's sometimes you need to round your numbers. Actually, round it's just the round towards the nearest integer. It can be both to the upward or downward. So round 2.51 equal to 3. You can use also fix. In this case, it just eliminates the decimal part of the real number. So it's just to remove it and nothing more. And important in math operations, it's the sale and flow. Sale, it means you should use if you need to find the integer which is closest to your real numbers, and floor if you need to find the nearest lower integer. Is it clear? Okay. You will need it often when you will use some loops or cycles in the nearest future, when you will need to perform some number of steps, for example, and it should be and must be actually an integer number of steps. But sometimes you should round your variables to decide when you need to stop. Okay. Anyway, you should know what is sale, flow, round, factor. It factorizes. It means it's factor 6. It means that you find how it expanded on the multiplication of the simple numbers like 2 and 3, and the greatest common divisor. Okay, it's clear, right? Yeah, much more you can find at any, I don't know, in the internet or somewhere else. But this is the most important ones. Then, logical and relational operations. When you make your program, you often need to comparing some quantities or some variables, and in this case you need some logic operations. First of all, you know that Boolean number, there are Boolean numbers which have two types. One means true and 0 means false. The operator greater than, operator lesser than, greater than or equal, lesser than or equal, it's important that equal, when you want to compare two numbers, not to assign some numbers to variables, but you want to compare some numbers, you must use the two signs of equality together. Yeah, it is important, no, not one. And some other operation. Oh well, not equal again in MATLAB only. It's tilde, yeah, tilde times together tilde and sign of equality. Wow. Okay, for example, in C, it will be like. I mean stress sign and equality, different from here. So also you can use operator and, or, and again not. Here is an example. If x is equal to 1, y is equal to 2, n is equal this piece, these guys, and these guys, you can see the answer will be false because this notation means that simultaneously your x should be lesser than 3 and y should be greater than 0. And you see that x equal 1 and that is not true. But if you try something like this, so you replace the symbol and with symbol O, with operator O actually, then it will be true, because it means that only one of these conditions should be true, not both of them. Do you understand differences? I mean the difference here. In first case, both conditions must be true. In the second case, only one first or second condition must be true to give you a true answer, true result. Okay? Yeah, so it's not some very special case. You actually often will need something like this. When you write your program, you often need to compare something, and sometimes you need to proceed with some calculation only if the set of instructions is true simultaneously or not simultaneous. Well, we are coming to our main topic for today. It's vectors. So my first, the most important question, what is the differences you know between the vectors, set and arrays? Okay, first of all, what is the difference between sets and vectors? Or, for example, some vector and some set. What is the principal difference? Who knows? Which number? Yeah. But what means direction? If you sets is actually set of number, for example. Yeah, it can be set of anything. Well, yeah, it's maybe it's a bit different. Set in general, it can be set of anything like tables, for example. But well, okay, if it's set of numbers, but vectors, it's also set of numbers. You can write it actually quite the same, just for some row of numbers. What is the difference? There are no directions in the row of two numbers, two rows of numbers, I mean. What is the difference? Which one between? No idea. Yeah? Oh, pardon, can you say it clearly? Yeah. Yeah, you're right. That's what I want to hear. That yes, the main differences between these two that sets in sets you are not interested in the order of your elements, in the arrangement of the elements. But vectors, it's actually some ordered set where the placement of each element is important. And arrays, it's actually like a matrices. It's actually kind of multidimensional vectors. So vectors, it's one-dimensional arrays, to say. So that's the easy example. For example, if you have two sets like this one and inverse one, it's the same set because it has absolutely the same element from 0 to 5. There is no difference in these two sets. But if you take it as a vectors, they are not equal. They are actually opposite here, I guess. Yeah. No. They are just not equal. And matrices, for example, it's two-dimensional arrays. It's kind of it can be represented as a set of vectors. And arrays can be like a tensors, for example. It can have up to infinity many dimensions. No, well, you can imagine three-dimensional arrays if you imagine the row of number which go, perpendicular to the screen in the third direction. Sorry. A bit more about vectors, how to assign them. The first way to assign them is to, I hope you remember this operation. The first number is the start point, in the middle is the step, actually, and 100 here is the end point of your vectors of your array. So it's give you 0, 1, 2, 3, 4, 5, and so on. If you put here 2, you will obtain something like 0, 2, 4, 6, and so on with step 2. Okay, it's a very useful combination, but you can also set the vectors directly by this notation. I mean, just to put the square brackets and numbers inside these brackets. The important thing that it's related to the matrix representation and to the multiplication of the vectors. So with linear algebra, the other words, then you can have a row vector and column vector. To assign a column vector, you need to put these signs near the between the numbers. In this case, you will have something like this. It's important if you decide to multiply, for example, two vectors, like people do it in linear algebra. In that case, you will need always the first row vectors and the second column vectors. The operation which convert one of them to another calls transposition of matrices or vectors. The third way how you can assign vectors, it's actually here is just an example. As I said, your complex number is also kind of representation of two-dimensional vectors or vectors on planes. In this case, for example, -1 is the first coordinate, 2 is the second coordinate. And on the complex plane, here you can see that I set the vector of vectors. But by the way, it's also very important thing that if you have one kind of variables, you usually have a possibility to assign a new type of variables which will be a set or a vector of variables the same type. You mean you can set the vector of integers, for example, the vector of complex number like here, you can set the vector of vectors, which is actually a matrix. So you can set the matrix of vectors, I mean matrix with elements not real numbers, but vectors, and so on. Actually, here we move to the more complex things like structures. But okay, here I just put another vectors like a combination of these four, and by the function compass, draw it, nothing more. Yeah, and here the last example how to assign vectors. You can actually use a mathematical expression to assign the vector components. For example, here you can see I use some numbers, some functions like exponent or square root. So you have a range of possibilities to assign your vectors. This is an example why you need your vectors actually. It's a simple mechanical problem when you have a point. No, it's absolutely arbitrary numbers, nothing important in these numbers. But you have a time variable, you have in three-dimensional space for the point, you have x, y, and z coordinates. You have three components of velocity for this point. You have three components for the acceleration for this point. So in total you have 10 variables, right? But you can do it much more beautiful and useful if you will use a vector form. You should understand that the set of three coordinates give you just one point, which is a radius vector of your point, right? So you can use, for example, R1 is just 2, 2, and 3. It's a vector. R2 equal to 3, 6, and 4. And nothing more. Absolutely the same for velocity. You have three components of your velocity in three-dimensional space, but you understand that it's the one vector of one quantity, you can find the norm actually of this velocity, but these three components give you just one vector, which is 17, 32, and 12, 13, and 32, and the same with acceleration. So it's very useful to use vectors just to make your data more readable, more useful. And MATLAB already can make any manipulation with your vectors. For example, it's also the important differences from the languages like C++ or something else, that MATLAB already know how to multiply your vectors, how to count your vectors, how to divide your vectors, and so on. So if you just write it as a vectors, you can easily use them in any of your equations. Further about vectors. First of all, while I said that MATLAB know how to multiply and sum up your vectors, in some cases, in many cases actually, you need to use special operators. It means, I try to describe it on this figure. Vectors, if it's coordinate vectors on plane or in 3D space as well, it means some point or some radius vector. Some point actually which you want. Oh, I'm sorry that you probably almost cannot see one of these vectors because it's red. But okay, I just want to show you that you can go this way, okay? from the first vector and then go along the second vector to reach this point. Or you can go directly from here to the same point. So in this case, this large vector will be the sum of this vector plus this vector. Is it clear? Yeah, so it's quite simple and you probably should know it. But if you make a projection on the coordinate axis, for example, this is projection for these vectors, this is projection for red vectors, and the same for y-axis, you will see that the projection of the white vectors is actually as a usual sum of x-coordinate of these vectors, and y projection of the white vectors is actually a simple sum of the projections of these two vectors. Okay, I mean that it means that if you want to find the sum of two vectors, like for example v1 and v2, you need just to sum their coordinates. It means 2 plus 1, 4 plus 2, 6 plus 3, and 8 plus 4. Sorry, it's a four-dimensional vectors. Okay, of course, but it doesn't matter. And oh yes, sorry. and here it's not. Which symbol should be here? Plus, of course, here should be plus symbol because this operation give your summation of coordinate summation. When you sum up x coordinate of x vector, then you sum up y coordinates and so on. Is it clear how it works? I mean, yeah. Okay, so finally you have some new vector, actually this white one, which is the sum of these two initial vectors. This is the idea, and absolutely the same things. If you need, for example, you can see here, if you need to divide or multiply two vectors. Well. Yes, and cross here, it's a function cross AB. It's so-called vector multiplication. There is a scalar multiplication of the vectors, and this is another one vector multiplication form, which you will learn on your. You should be know it from linear algebra course. Well, it's actually all the most important thing about vectors. You find some more information in your tutorial this week. But the idea is here that you can represent some of your variables as a vector, which is arranged or ordered sets of some other variables like an integer or real numbers. And you have some special operation how to manipulate with the vectors to obtain the new one. And it's very useful, and it's vectors one of the most important concept of, I don't know, even in science. Let's see. Well, now I want to speak more about the plots, about how to, actually it's this part related with the data analysis. If you want to understand your data, if you want to visualize it, if you want to decide is your decision true or false, often you need to plot your data, and you can do it by different ways. And MATLAB proposes a lot of possibilities for such visualization. For the simplest one is 2D plot. Here you can see that I just set some vectors x, not I, okay. Well, then I put actually another two function, vector of two function, which is sine x and cosine x, and this is the function plot xy. You probably already know, yeah, this function. It gives you just a simple row plot for these 5 points for this thing. Another thing, subplot is just an additional feature, but bar it's the main command for the function of bar plot. Here, rand, it's just a randomizer. It's just a function which gives you a matrix of 12 on 3 numbers actually. So it just generates your data. And stacked, it means that all your histograms are one into another, as you can see here. And you can also use a color map. More than this, it is not on here on the picture, but you can also, and you should actually write some comments to your graphics. You should use title, first of all. You should use labels for all your axes. For example, that is some can be, I don't know, stress and strain or something like that. And you also can use a legend. What I want to tell you, it's really important that along with comments in your code, you use as much as possible descriptions on your plots, because it's actually the same story. You can plot something, and in several months you cannot understand what it was specifically. But so, and in our course, please also label all your graphs and use title and use legend. Okay. The next thing to analyze your data is the histogram. You can see again here that I create some range. First of all, it's from -3 with step 0.2 up to 3. Then I use some random generator which to assign some values for this for each of these data, and it gives me, as expected, normal distribution for these values. And then function hist yx give you a histogram for your data. Very simple. Well, it's more peculiar thing. It's actually a polar plot. Usually, well, it's sometimes it's needed, but it's a more specific case. Here again, you just, for example, to set the range for your time and calculate the polar t sine 5t. You know that in usual plot it will be how the sine function looks like, but here you can see that it is different. I suppose you should learn in the analysis course. Very nice function, mesh mesh grid can give you some kind of surface in three-dimensional coordinate system. You can see here that we generate two vectors, and then please pay attention for this dot and power operator. It means that we take to the power of 2 each element of these vectors, not only one, not something else, but each element of these vectors we takes to the power of 2, and then surf x, y, z just gives you this surface. Well, and the last, but as I said, important thing which I want to show you, it's about comments. And you can see here actually a solution, well, one of the solutions for the problem which you have as your first coursework. But you can see also a lot of strange words here, maybe real strange. Well, the first clear, it's for any reasons. It's nice always to clear all the variables, because if you already have the variables like ABC, it's nice to start with the blank. Then you need to input all the 3 coefficients, coefficient of x to the power of 2, coefficient of x, and some constant term of your equation. And then you need to calculate your roots. And finally, you need to display your results. Yeah, I'm sorry, there was a small mistake in the quiz, which some of you spotted, that there were no commas there. Sorry about it, but I suppose the other variant were much more mistaken than this one. So I'm sure you find the true choice. So this is the decision, but I want to stress to pay your attention on the comments. It's just maybe stupid example, but it's important that then you write comments like this. You know that comments you can make with this operator, and after this operator you can write anything you want in this line. So the first, for me, it's a good idea to write who is the author of this program actually, and year. Because if someone else take your program, he or she can well, need to ask you something about it. Then it's a good idea to write some descriptions for this program. Sorry, we have almost 10 minutes more. Yeah? Sorry, I can't hear you. Pardon, you mean should you make the same? Or pardon? Yeah. Commas? Okay, well, okay, with commas, okay. Now the most important thing which I want you to understand me, that you need to clarify aim of your program. For example, that this code aims to solve a quadratic equation. You need, for this, it requires to set from the keyboard some coefficients. then you can write how you solve this equation. You find first discriminant, that do anything else. So please comment it's just a proposal how to do it. You can find your own style, but please, the mandatory conditions that you write any meaningful comments for your program, okay? Again, it's also if it's a big program where you have a lot of different variables, especially with some dimensionals like meters, centimeters, and Celsius, and so on, you almost must write the list of your variables with the dimensions of your variables, because it's crucially important to obtain the right answer. And the final, if you set by yourself some functions, you need to have the list of functions. And the very last but crucially important thing, that please write me only in emergency cases, okay? Because this week I wrote many tens of emails to you, and it's a real good idea to use course discussion board for this. There are many advantages for this. First of all, because most of you have absolutely the same problem. And it's not reasonable to me to write each of you the new answer. So if you raise your question here, we can answer it, and many people can see these answers. So please write it on almost only here. Well, the second thing, that besides me, many other people like our GTAs or Anastasia can answer you via this forum, okay? And it's much faster than I physically can do it. So again and again, please use this discussion board and write to me only if you have something really important and I don't know, case of emergency, okay? In this case, so.